So in this episode, I'm going to be doing some additional problems on statistics. So let's dive right into this. So number 1 through 3 refer to this curve, which is showing a scatter plot, each representing low temperature and high temperature of 8 days in September in a certain city, measured in Fahrenheit, line of best fit. Okay, see, you should just skim it. Based on the line of best fit for the data shown, how many degrees does the high temperature increase when the low temperature increase by 1 degree? So as usual, you should try these problems first on your own by pausing the video and then unpause it to see what the solution is and to see how I think through them if you got stuck. So this problem is just asking, what is the slope? Because the slope of this line is change in high temperature over change in low temperature. So when the low temperature increases by 1 degree, how much does the high temperature increase? So this is in a scale of 5 degrees per division. Okay, so we probably need to pick some nice points. For example, this is a nice point because it's 60, 70. Okay, is there another nice point? Maybe this is like, if you estimate it, it's like 58 for the y value and 50 for the x, something like that. Okay? Unless I just really cannot see with my eyes where another nice point is, like exactly on the tick marks, but we can just probably estimate. So here was the nice point. Change in y over change in x is 70 and 60. We take a difference from, let's say this point. What was this one? That was like 58, you said, right? For the y, and 50 for the x. This is the slope, so that is what? That's 12 over 10, right? Which is 6 over 5. What's 6 over 5? That is like 1.2-ish. Well, exactly 1.2. So what's the closest one? B, 1.3. Okay. What is the predicted high temperature of the day when the low temperature is 58? So let's go to the line of best fit. When x is 58, what is the y value? It's about 68, something like that. Answer is B. That's the best answer. Okay. So just testing if you can use that line of best fit. Number 3. Among the 4 days marked 1, 2, 3, 4 in the scatter plot, on which day is the difference between the high temperature and the low temperature minimal? Okay. So how can we quickly eyeball this? If the temperatures were the same, they will have the same x coordinate and y coordinate. So we want to pick the one with the minimal difference. So we want to pick the one whose x coordinate is closest to the y coordinate, or if it's exactly the same, even better. All right. So day 1, this is like 58-ish. This is 64-ish. Okay. We could probably do better. Maybe. So day 2, this is 60 versus above 75. That's worse. Okay. This is 60 something at 8. So it's getting worse there. So it's actually this one. That actually looks like the best, right? Okay. So I just quickly did those differences in my head. Again, if they were exactly the same, the x coordinate equals the y coordinate. So you want to pick the one that's closest to that. You're not picking the one that's closest to the line of best fit because that's not what's happening in the line of best fit. Okay. Number 4, based on the histogram above, what is the average number of hours worked by the 20 salespersons in company G? So how do we do this? This is a histogram, and it's like a frequency versus hours worked. Frequency meaning number of people. So we got to average them all out. So there's 20 people total. So we're going to divide by 20. Okay. Now we got to sum up all of these numbers. So there's 3 people whose hours worked is 30. So 3 times 30, or 30 plus 30 plus 30. So 3 times 30, that's easier. Okay. 5 people was 34. So 34 plus 34 plus 34 plus 34 plus 34, or 5 times 34 plus, and we go on, 9 times 40 plus 2 times 45 plus 50 times 1. Okay? If you put that into a calculator, I'm assuming this one you're allowed a calculator, that's 38. Okay? Pretty easy. Okay, 5 and 6 refer to this. This is frequency distribution, the same as this. Table about distribution contain 40 numbers, okay? These should total 40, which if we eyeball looks like it, right? What is the difference between the average of the numbers in list B and the average of the numbers in list A? Okay, so how can we do this? Or do we have to actually compute it? Let's actually compute it. I don't think it's that hard for this one. Okay, difference between the average of the numbers in list B and the, okay, so for list A, for the number 0, there's frequency of 8. So 0 times 8, or again, we're doing 0 plus 0 plus 0 plus 8. So you're adding 8 zeros, so 0 times 8, so I'll just write it, plus 4 times 10, because there's 10, you can think of frequency as people, 10 people with the number 4. Let's think of it like that. Okay, so on and so forth. So 5 times 12 plus 6 times 10 divided by 40. And what is that? This is 40 divided by 40, that's 1, plus that is, what is that? That's 60 over 40. Okay, can we use the calculator for this? This is 100 plus, actually this is 160 divided by 40, that's 40. That's not that bad for here. All right, for B, we do the exact same thing. 7 times 10 plus 10 times 8 plus 11 times 10 plus 15 times 12 divided by 40, okay? If we aren't allowed a calculator, what is this? 70 plus 80, 150 plus 110, that is 260 plus, that's another 6, that's a 260, right? That's 320 plus 150, that is, did I do this right? This is 80 plus 150 plus 11 plus 110, that is 260, 320, and then 440 divided by 40, which is 11. This would be 4, sorry, not 40. That doesn't make sense at all. It should be 4. Okay, so what is this asking? Average of, or the difference between the average of the numbers in list B and the average numbers in list A. So 11 minus 4, 7. Okay, so you just have to compute it. But that's how I thought to do it, at least. Okay, list C contains 80 numbers. Then the 4 numbers in list A and the 4 numbers in list B. Let M, lowercase m, be the average of the 80 numbers in list C, and capital M be the median of the numbers in list C. What is the value of M, lowercase m, minus capital M? So what is lowercase m? Okay, what did we say this total up here was? If we, 40 times 4, that is 160, right? So this was 160 over 40. Okay, so instead of recomputing everything, we just need the sum of all the numbers in both lists. We have the sum of list A, which is 160. We have the sum of list B, which is 440. Let's add them up. So lowercase m is 160 plus 440, and now there's a total of 80 numbers. Okay, so this is, what is that? That's 500, 600 divided by 80, which is 7.5. Okay, and then how do we get the median? Okay, so there is 80 numbers, so we need the middle 2 numbers, the 39th and 40th number. or the 40th and 41st, something there, okay? It's an even amount of numbers. So we need to take the middle two and then average them. Okay, which one would be the middle two? So conveniently, these are in sequential order. So let's just sum up, let's just count to around 40, and then we'll find out which one is the middle. If it's like in between something, then we got to be careful. But if it's all within like this group of 6, for example, then we might be good. Okay? So actually, since this is in sequential order, the middle two numbers should be the last one here and the first one here. So it would be the average of 6 and 7, which is 6.5, right? So capital M is 6.5. So I didn't even have to count anything because these are already sequential, in sequential order. Okay, we just had to use that concept that since it's there's an even amount of terms, we got to take the middle two and average them. The middle two must be the last one here and the first one there. Okay, so the difference between that, there's just 1. Okay, pretty simple actually if you understand the concept. Okay, the figure above shows a standard normal distribution with mean of 160, standard deviation d, including approximate percents of the distribution corresponding to the region shown. If the value 148 is at the 12th percentile of the distribution, which of the following is the best estimate of the standard deviation d of the distribution? So if it's in the 12th percentile, this is the 2nd percentile, this is the 14th percentile, okay, 0 percentile, 100 percentile. This is 2 percentile, 14 percentile. Then 12 is like right here, somewhere there. This is in between these two. These standard deviation. So we could set up an inequality. Okay? Best estimate of the standard deviation. So 160 minus 2d. Okay? The value of 148. It is 160 minus 40 minus 2d. That's down here, but we said 148 is at the 12th percentile, so this is smaller than 148. And similarly, 148 is less than 160 minus d. Okay? So actually, we should split this up into 2 inequalities. 160 minus 2d less than 148, and 148 less than 160 minus d. So we can solve for d in these 2 separate branches. Okay, so this would be 12 is less than 2d. So 6 is less than d in this branch. And then over here, it would be d is less than 12. Okay, so d is greater than 6 and less than 12. The only answer is B. Okay, so the key here was this is at the 12th percentile. So somewhere here, which is between these two. Okay, last one. The tables below give the distribution of ratings of 2 different laptops by 100 people each. Okay, which of the following is true about the data shown for the ratings of the 2 laptops? Okay, so let's look at choice A. Standard deviation of the ratings of laptop A is larger. Is that true? Well, you can clearly see that this data is skewed because there's more frequency over here than over here. Versus this one, it's more even between all the ratings. So there is, since this one is more spread out, is what I'm trying to say, versus here, it's more clustered in the 5 and 4, right? So the standard deviation of B would be larger. So not A, and I just said B would be true, so let's hold that off. Standard deviation of 2 ratings are the same, for sure not. If that's the case. Standard deviation of 2 ratings, you could totally calculate it, but it will be a pain to calculate this by hand. Even with a scientific calculator, it's a pain. And with a graphing calculator, it's really easy. You can just type in everything. But you don't want to do that still. You have to understand standard deviation. So where is the mean of this guy over here? It's probably somewhere over here. More like toward the 4 range. Okay, because if you add them all up, the ratings up and the with each of the frequencies, it'll be somewhere over here. Versus this one, if you add them all up and then, or you average it, the mean is somewhere around 3. Okay, so if the mean is the reference, there's lots of terms over here and over here, far away from the mean. So the standard deviation is high. Versus here, let's say the mean is like 4, okay? Most of the terms are actually over here. So the standard deviation is much smaller. There's some terms here, but not as many. It's more clustered around here. Remember, standard deviation is with reference to the mean. Distance from the mean. You can kind of think of it like that. That's variance, actually. Yeah, so variance is standard deviation squared, by the way. So that's why the standard deviation of B is bigger. Okay, and that's it for this video. So hopefully this one made sense. This is important to understand. If you don't want to go calculate it, it's a pain, honestly. So you should really understand the concepts of standard deviation in like a skewed case and a normal distributed case and all that, all right? Okay, as usual, please like and subscribe if you found this helpful, this video to be helpful. If you learned something, please like the video and subscribe to show your support to the channel.